Hi, so I'm going to be going over 13.4a and kind of just looking at this. If the problem says to consider the motion with these three descriptions. And so the first thing that we want to do is be able to get the expression for the Lagrangian description of velocity and acceleration. So this is actually pretty simple, very similar to what we've done in the other problems of just taking the velocity here, taking the derivative, and I've broken it out and took some of the steps here. So we take the derivative of this x1 we've described up here, and by doing d sub dt and plugging this in, it's actually pretty simple of just like whether or not you just want to FOIL this out. But very clearly it shows that these two terms kind of can't go away and you're left with this guy here. And so similarly, we're just going to continue on with the acceleration for component 1, and we're going to take the derivative of this v velocity here, and that really just gives us the same thing, like the derivative of x2 e sub t is equal to x2 e sub t. So that's the component 1 of the acceleration vector, or the acceleration. So the second one, very similarly, we're going to take the derivative of x2, and so very similarly, we end up getting negative x of 1 e sub negative t. And so to get the acceleration of that, the number 2, we're going to take the derivative of the velocity of 2. We end up getting negative x1 e sub negative t, just based off of how derivatives work. And so for the final component, we're actually going to end up taking v sub, for v sub 3, very similarly, since we don't have any components that are dependent on t, we end up getting 0 and 0 for that final.